Hello, everyone. We just finished Trig 007, and in that we actually covered some more identities. Now we're getting ready to do the law of sines. So the law of sines is another set of equations that actually allows you to solve a triangle that isn't a right triangle. So we've been mostly working, or we've been basically just working with right triangles so far. So what happens when you have an oblique triangle? That is a triangle who has one angle bigger than 90. Of course, you can't have a triangle with more than one angle bigger than 90 because then that would be bigger than 180, and that's the total sum of the internal angles of a triangle. So in this case, we're handling oblique triangles, and there's really two ways to do that. One is the law of sines, and the other one's the law of cosines. So I'm going to first derive that for you, and then work an example showing you how to go about using it. So let me turn on my document cam. And I have a triangle drawn here already, and the normal way that we label triangles in trigonometry is we normally give a big letter to the angle, and then the side opposite that angle is given the same small letter. So big A, side little a, big B, side little b, big C, side little c. Okay, so what I want you to do is think about this as if it's a right triangle. I know that blue line is not exactly perpendicular to this bottom one, but it's supposed to be, and it's supposed to be represented by the distance h. So that perpendicular to this side B is breaking this big triangle up into a small triangle. Okay, so here's a small triangle and then another fairly good sized triangle. So from this, we can say, well, if I treat this as a right triangle, then I know the sine of C is equal to opposite, which is the H, over the hypotenuse, which is the A. So that works kind of nicely. But if I look at this right triangle, the one formed here by that vertical line, and then this one, then I can say the sine of A is equal to opposite over hypotenuse. Of course, the opposite of this right triangle is again H, and the hypotenuse in this case is C. So in both cases, I have a common H. So if I solve this equation for H, I've got H is equal to A times the sine of C. And if I solve this one for H, I've got H is equal to C times the sine of A. So ignoring this outer part and just looking at this, what I end up finding out is that the sine of C over the side C is equal to the sine of A over the side A. So that gets us two parts of the law of sines. Now if I take and break this up into another perpendicular vector, so I'm going to take a line. I'm going to take a perpendicular line that's perpendicular to side A, and let's call that length just D or something like that. So I'm going to take this guy right here and call that length just, let's call it X, what the heck. So that length from there to there, and it's supposed to actually end at that vertex, is actually X. So that's now broken this triangle up into this right triangle and this right triangle. So now what we can do is we can say the sine of B is equal to opposite, which is X, over hypotenuse for this triangle, which is C. And we can also say the sine of C is equal to opposite, which is X, over the hypotenuse in this case, which is B. So now we can take these two again, solving for X. I get C sine B is equal to B sine C. So I've already got sine B over B. I've got sine C over C. So when I divide both sides by C, that's sine C over C. Now I've got sine B over B. And that's our law of cosines. It gives us the ratio of the sine of the angle to the opposite side is equal to the ratio of the sine of the angle to the opposite side, and so on and so forth. Now, as long as you know two angles and one side, or two sides and one angle, you're good to go on solving for this particular triangle. So in other words, working out the rest of the angles and stuff for the triangle. So for instance, here's an example of how to use the law of sines. So if I take a triangle, let's say it looks like this. And let's say this side is 52 degrees. And let's say this side is 70 degrees. And let's say the side in between them has a length of 230 centimeters. I can use the law of sines to find out this side, and of course I already know this angle. So for instance, if I want to know, let's call this side C. Let's call this A, and let's call this B. Then of course this angle right here is big C. Big A is 70 degrees. Big B is 52 degrees. And of course, lowercase c is 230 centimeters. So I already know that A plus B plus C is equal to 180. So that tells me that 52 plus 70 plus C is equal to 180 degrees. So that tells me C, if I subtract 70 from it, I get 110. If I subtract 52 from that, I get, well, if I subtract 50 from 110, I get 60, and then I take the other two, I get 58. So this one's going to be 58 degrees. So I now have that angle is 58 degrees. That's one of the answers. Now, I could ask you for any of these parts. I could ask you for little a, little b, or big C, but I'm going to work out all of them. Now, I don't need that to do this, but what I do know is that the sine of 70 degrees over the opposite of that, which is A, has got to equal the sine of C, which we now worked out as 58 degrees, over 230. So see what I did is I chose an angle opposite a side that I knew so that I could have one whole ratio right, and then I can work out the rest. So in doing that, all I have to work out is that the A is equal to, now what you're supposed to do when you have a simple proportion like this is you cross multiply. So you can say A times the sine of 58 degrees. I'm sorry about this looking so rough. I was trying to just do it on the fly, but I decided to take a little bit more time. Let me scratch that out. So when I cross multiply, I get A times the sine of 58 degrees is equal to 230 centimeters times the sine of 70 degrees. So I can now divide both sides by the sine of 58 degrees. And that will give me A. So A is going to be 230 centimeters times the sine of 70 degrees divided by the sine of 58 degrees. You got to make sure your calculator's in the degree mode when you're doing this. So let me first check. And in fact, my calculator is not in the degree mode. So I need to change that to the degree mode. And working on that, hold on. So I'll do the sine of 70. So I'll do the sine of 70, trig function, sine, and actually I couldn't find how to switch it right quick, so I'm going to actually convert it on the fly. So I'm going to say times pi, and then I'm going to divide that by 180. And when I do sine of 70 times pi over 180, that of course is the sine of 70 degrees, and that gives me 0.9396. 0.9396. And actually, since I didn't round that properly, I'll go ahead and write the next 9. And then the sine of 58, I'm going to do the same thing. I'll say trig sine 58 degrees times pi divided by 180 degrees, and that is in fact the sine of 58 degrees, which is 0.8480. And the last digit I'll write is 5. So now if I divide 0.93969 by 0.84805 and then multiply that by 230, then I should get, let me do this. So I enter that divided by that. And now I'm going to multiply that by 230, so times 230, and lo and behold, I get A is equal to 254.8, which I'll call 254.8 centimeters, which using sig fig rules, I really should call this about 250, but I'm going to call it 255. Just because really there's only two sig figs in sine and cosine are in the sines of these angles. So I really should probably only take these results out to 3 for intermediate calculations and round the result to 2 significant figures. But I'm going to go ahead and stick with 255. That's probably more likely what you get with any kind of computer system. Now I've solved for side A, and finally, if I want to do for side B, then I just have to do the sine of 52 degrees, which is big B, over little b, is equal to, again, something I know, and something I know would be sine of 58 degrees over 230 centimeters. Now, I could actually use the sine of 70 degrees and 255 centimeters, but that's something I doubly calculated. I calculated the 58 to get it, and then of course I calculated it, so that's twice chances for me getting errors. So it's probably better to stick to the thing that only have one error. Again, I cross multiply, I get B sine 58 degrees is equal to 230 centimeters times the sine of 52 degrees. And then, of course, that gives me B is equal to 230 centimeters times the sine of 52 and divided by the sine of 58 degrees. We've already worked out the sine of 58, so I can say this is 230 centimeters times sine of 52 over the sine of 58, which is 0.84805. So I got to work out the sine of 52. So I'm going to say trig function sine. I'm going to say 52 times pi divided by 180. And I'll get 0.78801, 0.78801. Now in principle, since I only used 2 numbers there, I should probably go 1 more, which would be to that 3rd number. Same thing with this. I really should go to at least that 3rd number. But in the end, I should really technically, by the rules of what we learned in physics, propagation of error, I should probably round this to just 2 sig figs. But again, I'm going to do 3 sig figs. So now I'm going to take that value and divide it by, I'm going to divide that by this other value, which is 0.848, which I can't do right now. So divide by 0.84805, and then I'm going to multiply that by 230. And lo and behold, I get 214, I get 213.7 centimeters, which I'm going to say should actually be called 214 centimeters. So that's the answer. B is equal to that. So now I've managed to solve this entire triangle using the law of sines. So you just got to remember the law of sines says the sine of an angle divided by the opposite side is equal to the sine of another angle divided by its opposite side. And that's, of course, equal to the other sine of the other angle divided by its opposite side. So that's what the law of sines are. That's how you derive them. So they make sense to you, and that's how you actually apply them. Well, I hope that helps you understand and better understand the actual law of sines. My next video is going to be the law of cosines. And I'll probably do the same thing. I'll probably do a derivation and then follow that up with an actual example. Well, I'll call it a day. I hope you enjoyed it. Have a good day.